Hello, I'm Professor Julio Rezende. This is my presentation about main station presented during the mission 65, organized by Space Analog Station at Marte. In this presentation, we will be discussing some topics, as you can see here. We are going deeper in the next slides. First of all, I'd like to share the concept of our imagine space analog station, not analog, but a possible future space station operating on Mars. In our case, we will be operating here. The main station is imagined to be operating here. And in this presentation, we have five dimensions. First of all, I'd like to show the concepts about the internal design of the main station. In the main station, I imagine three models integrated. One will be alpha model, used for the prolonged activities, to sleep and also to relax, is the silent sector. The second one is the beta model, is for the social use and leisure. The third one is the gamma model, for the scientific use and also working, also control of the mission. In the alpha model, we have the bedrooms, also a study room and rest room. In beta model, we have the kitchen, dining room, and living room. In the gamma model, we have the training and control and research room. In terms of this facility, we can see here a lot of different facilities about of these three main models integrated in the main station. In this case, in the alpha model, we are going deeper. You can see here the 13 bunks. In this case, we are imagining the possible infrastructure to receive 26 astronauts. Also, they keep the luggage. Also, two bathrooms. Also, a study area. This also it's possible to see here a concept about the dormitory. Also, some ideas about the vertical garden in this model, and then some reasons for planes aboard is we can imagine some possible four reasons. First of all, is for evaluate the air quality. Also, it's important to bring nature to space habitat. This is related to psychological well-being, also connected to less stress and more healthy. The third possibility is the possibility of vegetable productions bringing practicities and easiness to prepare fresh meal. The concept of pick and eat. This is very useful to the operation of the kitchen. Also helping the process of meditation. Okay, looking to the plants. Aboard of the first model that we are talking about, you can see here the different possibilities in terms of have connection with knowledge. In the first picture, it's possible to see an astronaut reading a book. In the second one, an astronaut reading a digital book in a computer. We need to look these different possibilities, but it's difficult to carry a library to space, and then in this case it would be better if you be using electronic documents. Okay, in this case it's very important we have a big library in terms of books and music and movies to astronauts have the contact with knowledge, different kinds of knowledge. In the second model, the beta model is for the is working living space. Also, you have the kitchen, dining room, and gym. In the living room, it's possible seeing this image concept about a design of a space analog space station in a Second Life. This environment was created by Michael Lowry, in this part of the International Space Flight Museum. In this picture, it's possible to see a conception of a living room with a swimming pool, piano, battery, and a place that would be happening concerts to the entertainment of the crew. Other parts of this facility, the beta model, would be the kitchen. Okay, in this area will be possible to have some plants in a vertical garden, as you can see here, using the LED lighting. In the second picture, it's possible to see a technology called Molly. It's a startup company. It's possible to see in a screen, a computer screen, a cooker presenting guidelines about the preparation of the meal, and the robotics is maybe using the image learning to read the labels of the foods, also complementing the guidelines from the what the guide is presenting in terms of the food preparation. Then this would be very interesting to have this application in a future space habitat. Also, the conception of dining room. In the dining room, we would have the different turns of eight, having 8 astronauts for turn, because the area is not big. Also, in this facility, we have the gym. In this case, we have different photos from International Space Station showing the astronauts doing the different activities there. And then we need to think something about also relate to avoid the bone losses and keep the healthy of the astronauts. And the third model is the gamma model. And the gamma model is to operate as a control room and research room. Something interesting in terms of imagine the control center is an area responsible for the management of the all station, also the activities related to communication. And in the right, it's possible to see how the panel, the dashboard of the space vehicles had the evolution during the time. In this case, we have the Apollo in the 60s, shuttle in the since the 80s, and more recently the Dragon capsule from the SpaceX, just using uh, big screens, computer screens with different multitasking operating in different systems operating this in these computer screens. And then it's possible to imagine the operation of the this space station in Mars will be using controls based in screens, computer screens, with resources of multitasking. We imagine a board of the control room dashboard to uh, do the management of different elements. As you can see here, the greenhouse is related to the follow-up of the greenhouse is related to look the air, the levels of oxygen and carbon, also the water demand and consumption, also the temperature, the inner climate, also the demands of energy applied to irrigation and lighting systems, also examining the soil conditions, temperature, humidity, demands for nutrients and biomass, also how is operating the aquaponics, the operations of sensors, then the radiation, development of plants, also health or disease or the cycle of the plants, also the food production, the quantities and quality, and demands for nutrients, also nutritive elements, and possible threats and alerts to the related to the operation of the greenhouse system. Also, it's very important we have the follow-up of the health of the astronauts related to mental conditions, heart rate, calorie consumption, level of physical activity, how is the blood, the urine, feces, periodic examinations, reports, and alerts. Also, it's very important we look the operation of the power station, also the different sources of energy, like the kilopower based in nuclear energy, the solar biodigester from sanitation center, other sources, and also the consumptions, the demands. As example, you need more energy. If you need more energy to charge the electrical vehicles that will be used during the extravehicular activities, also make simulations and safety demands for the operation of these vehicles, also system operation. Also related to the sanitation center, we need to look the how much gas had been generated from the biodigester, also the sewage collected, sources of water type, if the water or the sewage is coming from the toilet, the food preparation, the humidity of the station, the how the sewage was generated from the each specific facility. Also, the produced water from, in this case, they reclaim the water that had been recycled from the and reused from these disposable sources. Also, water received from EVAs, because we imagine that will be happening extravehicular activities to collect the ice in the Mars landscape. Okay, and how and also the treatment of this ice, in terms of also this ice will be used to produce water. Also, how much water stored we have. Also, the air, the analysis of the air, also necessity to remove the humidity as if the temperature is working. Also, about of the main station need to control the some levels of water, food, temperature, and humidity in the entire station. Also look the exterior conditions, like the evaluation of external conditions, the weather, the lightning, the wind, the possibility of dust storm, how is working the operation of the extravehicular activities, the levels of oxygen and energy in the vehicles and provided to the astronauts. And then, in this case, from the main station, will be controlling different levels and activities operating in the entire station. In this case, we have a research room, okay, and then now we'll be talking about the second dimension of this presentation, some applied technologies. We imagine that we'll be operating different technologies just used on Earth, like ovens, fridge, virtual reality headsets, also the spy hydro message, disco lightning, communication technologies, antennas, and possible sources, resources to generate in situ, transport for Earth. We imagine that part of the of equipments will be maybe produced using 3D printers on Mars, but a greatest part of the equipment will be transported from Earth. The third dimension is related to the management. We are imagining organizational structure and positions based in four astronauts: the commander, the executive chief, the chef, the general assistant. In terms of the commander, would be a person with a multidisciplinary background, someone with management or industrial engineering bachelor, present a high capacity of leadership, intercultural competency, high personal resilience. And some duties are the control of the extravehicular activities and rovers integrated with engineering center, also propose routines, operational protocols, also provide guidance to avoid risks, also conduct educational activities with and training of the astronauts, also preparation of for the extravehicular activities, And it's very also important they coordinate the communication with the national space agencies like NASA, ESA, and ISRO, and other space agencies around the world. The second position, the executive chief, would be an engineer, information technology specialist. This person would be, we have some duties related to monitor all operations, keep all facilities running, monitor routine maintenance, organize specific operations and responsible people, coordinated training, online content delivery, also follow up meetings, also organize specific operations and responsible people, stimulate self sustainability. Okay. The third position is the chef. The chef is a would be a cooker, a cuisine chef, a nutritionist, a gastronomer. You can see in the first picture here the image from the Matrix movie. It's possible to see the character of Keanu Reeves. Is Neo is aboard of Nebuchadnezzar ship, and all days they are he's eating the oat milk, and he's mentioned that this is very boring for him, and because all days is the same thing. And then part of the responsibilities of the chef is define menu, meals, food logistics, perform food preparation, waste disposal, cleaning, organization, maintenance, repair the procedures, assess nutritional requirements, uh, plan the availability of food, define the feed shifts. Also, based in this photo, prepare very creative meals. The meals and not to be bored. It's very important creativity. Each day have something different for the astronauts, and we will be combining these last two photos the food transported from Earth to the astronauts, and also food produced aboard of the greenhouse operating in the station, in the Mars station, okay, the Mars habitat. In this case, this food we have basil, pepper, and lettuce produced aboard the analog space station habitat Marte. And then we need to combine these two kinds of sauces. The sauces, the food transported from Earth, the food produced on Mars. And the fourth astronauts is assistant, would be engineer, information technology, a psychologist, or an artist. And some duties are the emphasize the team's well-being, create the interesting content to entertain the team, also food management, also the support the chef, also coordinate the organization of the dormitory, coordinate the team, manage the laboratory tools, study routines, and sample analysis. And this, in this case, this is the four positions that I presented for the main station. And now we will be talking about the astronaut training program. We are imagining some topics of training, the new skills based on situations identified on Mars, also how is the operation of all systems, also the new technologies that will be using on Mars, also positions and tests of each astronauts and the simulations. Also, we identified some videos that would be useful for to train the astronauts. Also, we reflect how much uh, water and food will be necessary to supply the astronauts. In this case, we are imagining one solid food by day to uh, attend the astronauts. Also, the 2.5 liters to prepare the food for astronauts. Also, 2 liters to bath by each astronaut. Also, the main station is a facility on Mars, uh, producing guidelines to other facilities. Some guidelines are related to daily routines, schedule activities, health occupation, health and environmental safety guidelines about how to maintain plants in specific space habitats, how to provide harmony and collaboration, make the astronauts comfortable about to be in space, stimulate cooperation, innovation, creativity, and co-creation, also emphasize the team's well-being, create interesting content to entertain the team, also stimulate self-sustainability. And now we are after talk about management. We are going to the fourth dimension of this presentation. Is related to protocols. We are imagining specific protocols in the main station related to harmony and good relationship and collaboration. Protocols to deal with stress and relationship. Protocols to organize the room. Protocols for plant maintenance, for food production, and also protocols related to maintenance. Uh, the protocols related to safeties are related to hygiene protocol, also the use of wearables to collect some data, like the calorie consumption, physical activities, and all this necessary other identify other resources to collect more healthy data. Also protocols to deal with psychological balancing and emergencies. Also protocols and simulations to deal with accidents. Related to protocol of occupancy, we need to think about parties, celebrate some specific days. Some days would be special days based in each specific cultures from the astronauts. If you have a Mexican, we have the Day of Dead or Dia de los Muertos. If you have a Brazilian, we'll, will be celebrate the Carnival. Also, if you have someone from United States or Canada, would be celebrating uh, the Halloween or the Christmas Day. Then it would be interesting. We have these have some parties, also celebration days related to some specific and special days celebrated on Earth. Also the spa day, a day for relaxing, also use of body games, also the yoga, practice of yoga and physical activities, also reading and content suggestions for the astronauts. And here it's also interesting to think about the food microproduction using the vertical gardens, the protocol for cultivation, protocol for maintenance and detection of adjustments, management of the plants, food collection protocol, protocol for rotation disposal of the plants, best time for irrigation, male, female, flower pollination, also plant cycle and plant lifespan. Related to 3D printing, 3D printing, we are imagining using 3D printer to print balls and plates, and also that will be used for to in the meal, okay, in the kitchen. Main utilities used in the kitchen of the station. Also related to the 3D printing, we are considered that it's necessary uh, the project, the CAD project, to print the objects. Also a process for recycling, like discard the ground out data to ground down the particles. Also ground plastic food if refined into smaller particles in a blender. Also use the small particles to melt and stored in a transform in a plastic filament. Also the additive manufacturing process with recycled filament. The last dimension of my presentation is related to the spin-offs. The spin-offs are some possible technologies operating on Mars, on space, but that would be used in our daily lives on Earth. In this case, we can see some technologies applied in the station to save water, save energy, and also to promote the recycling. These possible technologies also would be applied on Earth. Also, some guidelines that we'll be using in the station that will be applied on Earth will be is related to mental well-being, also daily routines and guidelines. It's related to health occupancy. Also, it's related to health, environmental safety guidelines. Also, a recycling mindset. And then these are some possible activities happening in the space station that will be operating on Earth too. At least this is my last slide. Is related to the impact of sustainable development goals. In this case, the operation of the main station would have the impact related to health and well-being, also the training of the astronauts, the education of the astronauts. Also, we are interested in terms of have a balance between women and men operating in the main station. In this case, if we are four positions, maybe two would be men and two would be a woman. Also, we are very interested about safe energy and safe water. They go 6 and 7. Also related to recycling, this is connected to goal 15. Also aspects related to management, connected to goal 16, and also looking for partnerships because also the main station is connected to other facilities, and also we have great connections with space agencies based on Earth. Okay, different space agencies from different nationalities. And this is my contact in Twitter and in Instagram. Also, my email, juliofdresend@hotmail.com. And then we are welcome to talk more about about how would be the operation of a space station based on Mars. Also, present more guidelines about how would be happening the space education. Okay. Okay. Thanks so much.